So for the first question, explain the meaning of differentiation from perspective of limits and the slope of the tangent line. Differentiation from the perspective of limits is defined as the limit of the difference quotient as the change in x approaches zero. This limit represents the instantaneous rate of change of function f(x) with respect to x.
For 1b, I'm going to list and briefly explain the differences between the product rule, quotient rule, and the chain rule in differentiation. For product rule, it is used to differentiate the product of two functions. For quotient rule, it is used to differentiate the quotient of two functions, while the chain rule is used to differentiate a composite function.
Right, so for question number 2, the question is find dy dx for the following function, which is y equals to x squared cos 4x plus 1. So the first thing we need to do is we apply the product rule, which is we let u equals to x squared and then v equals to cos 4x plus 1, and then for the u prime we just need to differentiate them, and the x squared will become 2x, and then for the v prime it will become negative 4 sine 4x plus 1, and then you just apply the product rule, which is u prime times v plus u times v prime, and it will become 2x cos 4x plus 1 plus x squared negative sine 4x plus 1, and then we just simplify the equation, and it will be 2x cos 4x plus 1 minus 4x squared sine 4x plus 1, and that's the answer for question 2a.
The next question that I'll be answering today is question B, which is y equals to ln times the quantity of x squared minus 1 over x cubed. We should solve this by following the quotient rule, which equals u prime times v minus u times v prime over v squared. Once we sub in the primes of u and v's, we should get the equation that is the second one. Once we finish the differentiation, we should finally get something that is along the lines of the second to last answer. By simplifying, we simply just split the deduction of both functions and fixing the x squared minus 1 and multiplying it on the right side of the deduction. Finally, we should fix up some of the top side, and we should finally get the answer of 2x squared equal 2x squared minus 3ln times the quantity of x squared minus 1, also in the times the quantity of x squared minus 1 over x to the power of 6 minus x to the power of 4.
For question 3, we are given the equation as y power of 2 plus sin in bracket x power of 2 plus y equal to 5. First, we differentiate both sides of the equation with respect to x. For the term x y power of 2, we apply the product rule, which gives us y power of 2 plus 2xy divided x. For the term sin in bracket x power of 2 plus y, we apply the chain rule, resulting cos in bracket x power of 2 plus y in other bracket to x plus dy dx. The derivative of the constant 5 is 0. Next, we combine all terms and group those containing dy dx on one side. Finally, we factor and solve for dy dx, and answer is minus y power of 2 plus 2x cos in bracket x power of 2 plus y over 2xy plus cos in bracket x power of 2 plus y.
Okay, for the last question, we will discuss about how to use linear approximation to estimate the value of fx uh, cube root 8.002 minus 8.002 to the power of 3. So, first of all, we'll let fx is equal to cube root x minus x to the power of 3. After that, we'll use the formula which is fx is equal to fx naught plus f prime x naught delta x. From the formula, we list the information that we know that S naught is 8 because it is closest to 8.002. X is 8.002. Delta x is equal to x minus S naught, which means that we will get that 0.002. So after that, we let f8 is equal to, and we get that the value of negative 510. After that, we differentiate fs and we will get the answer which is 1 over 3x to the power of negative 2 over 3 minus 3x to the power of 2. We evaluate f prime 8 and we will get that the answer negative 2303 over 12. After that, we just use the formula that we write before this, and the final answer to the correct four decimal places, we will get that negative 510.3838.
So the conclusion is techniques of differentiation are different ways we use to find derivative. They help us understand how something changes, such as how fast or how slow it is changing.
By choosing the right technique, we can solve differentiation problems more easily and correctly.